Welcome to the Crazy Hat Chemist. So today here is another great video. It's the 10th video in electrons and atoms. So let's get moving. Bam! So today we're going to be talking about the principal quantum number. Remember, there are 4 quantum numbers. Today is the principal quantum number. The principal quantum number is designated as a scripted lowercase n, like n as in Nancy. Okay, the principal quantum number, n, describes the energy of the electron and its average distance from the nucleus. That is a relationship between the size of where that electron can be and the energy of an atomic orbital. It is also called the shell. Okay, n is positive whole integers. That is 1, 2, 3, 4, 5, 6, 7, etc. N increases as the electron moves farther from the nucleus. So n equals 1 is closest to the nucleus. N equals 2 is farther than n equals 1. N equals 4 is farther from the nucleus than n equals 1, 2, and 3, for example. Each shell, that is n, contains n number of subshells, or values of L. We're going to be talking about L in just a minute. That's the next quantum number. Okay, for example, if n equals 4, then there are 4 subshells. That is values of L. Okay? The maximum number of electrons in n is 2n squared. Okay? Maximum number of electrons in n is 2n squared. Okay? As n increases, the electron moves further from the nucleus. So I think I mentioned that already before. So the closest n value to the nucleus is n of 1. The furthest is the largest n value, and they are positive whole number integers all the way up to infinity. Okay? N is like the rungs to the ladder. But the rungs are not equal distant, unlike a real ladder. Electrons can be placed at the rungs, but never in between the rungs of the ladder. This is a ladder, and we've actually already discussed this here when we were talking about light being emitted from an atom. Okay, and we need to first define a couple of things. The nucleus is right here. The rungs to the ladder are the yellow portions of this ladder. The rails of the ladder are the black portions. Okay, so you can have an electron at a rung to the ladder. That means you can step on a rung, you can place an electron there, and that first rung that is closest to the nucleus is n equals 1. As we move further from the nucleus, we can place another electron there if it is a multi-electron atom. And this next rung would be n equals 2. So as you move further and further away from the nucleus, you are increasing the rungs to the ladder. N equals 1, n equals 2, n equals 3, 4, 5, 6, 7, etc. Okay, I want you to notice something here, that the rungs, the yellow portions of this ladder, the farther you move from the nucleus, the closer the rungs to the ladder are. Until at infinity, there's really no difference from the previous rung. The greatest distance is n equals 1. That is the largest distance. That rung is the furthest away. Okay? Can you place an electron right here? The answer is, can you step right there on a ladder and be stable? The answer is no, and that is, you cannot place an electron outside of a rung. Those electrons must be placed on a rung. How about right here? It's really close to the rung, but it's not on the rung, so no, that's an absolute no. Can you place an electron in between n equals 1 and the nucleus? That is a no. Absolutely not. Also on that one. Okay, hopefully that makes sense for you. Okay, that's another cool video, and I want you to try to figure out what this hat is. Okay, what is this? Try to think of this. I'm in the dirt. I'm above the dirt. Am I an onion? No, I am a garlic. It's from my heritage. I'm a little bit Italian. Okay, give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I will see you next time for more chemistry.